Welcome back to Easy Gates, Gate 22 Easy Solutions. Once again, the next problem from control systems. A numerical answer type exploiting the basics of Nyquist stability criteria. Okay, a Nyquist diagram of G of S is shown in figure for K is equal to 1. Okay, that's very important. Okay, that data is very important. You have to understand for what K it is given. The Nyquist diagram of system G of S is given for K is equal to 1. Okay, you can feel like immediately it is something like the characteristic equation of the given system is something like this. So 1 plus K into G of S H of S is equal to 0. Usually that's a characteristic equation. So where K is a variable, now the K is given as 1. Okay, now what we are doing is we are plotting the curve, okay, when K is equal to 1 for the G. Probably H of S equal to 1. It's hidden from S. Okay, you straight away go for G of S Nyquist diagram. Okay, the open loop transfer functions Nyquist diagram. Okay, when K is equal to 1. So under this, as per the under this condition, it is given. So assuming no right hand side poles for G of S, that means what? No right hand side poles for G of S means the given system is absolutely stable, because it doesn't have any poles on right hand side. So the given open loop system is stable. So as per the Nyquist stability, Z is equal to N plus P. That's all you need to remember as per the Nyquist stability criteria, where P represents number of right hand side poles of whom means G of S that doesn't have any poles on right hand side, that is equal to 0. Now for the given K, as per the Nyquist stability, then what Z represents means Z represents closed loop right hand side poles. So for the closed loop system, it is talking about number of closed loop RHS poles, which we always dream for getting the number as 0. We never wish to have a closed loop pole on right hand side, even a single pole on right hand side. What about N? N is actually talking about encirclements of the critical point -1 plus 0j. So -1 plus 0j is the critical point, or you can also say the marginally stable point. Okay, so encirclements. So whether the Nyquist diagram is going to encircle this critical point or not. As per the given Nyquist diagram, it is not encircling. So the N is equal to 0. What is usually N? This N is actually positive for clockwise rotation. Okay. If counterclockwise, then N will be taken as a negative. Okay, that's a rule of thumb. Okay, as per the Nyquist stability criteria, we can take. Okay, but usually author to author, this will differ. Okay, people remember this was Z is equal to N minus P also, P minus N also, but we never know where the minus will come into play, because you will be remembering so many expressions as a gate spread. So let me keep it as simple as possible. Z is equal to N plus P, where P is representing open loop systems right hand side poles. Okay, so that is clearly ruled out. No poles on right hand side. It is given as 0. And as per the given Nyquist diagram for the G of S, it doesn't encircle, okay, the critical point -1 plus 0j. Therefore N is equal to 0 in this case. So therefore, when K is equal to 1, let me get into this. Suppose when K is equal to 1, what is given? So it's 0.4, it's 0.8 and -1 plus j0. So what is exactly the problem? Assuming no right hand side poles for G of S, the number of closed loop poles of R on the right hand side for K is equal to 0 is. Okay, so problem statement in the original paper is a little different, but anyway, it is meaning this only. Okay, so I have given in my own version, that's all, since it is memory based. You will see the actual structure and statements after reading the response sheet. Okay, yes, what we need to find out, probably the stability of the system. Okay, and how many poles are having the closed loop system is having on the right hand side. Okay, that means we need to find Z when K is equal to 1. Okay, so when K is equal to, K equal to 2, what is our Z? So K is equal to 1, Z is given. When K is equal to 1, what is Z? As per the data given, this is the point, critical point, -1 plus j0, we can say. What about this point? What about this point? Okay, we should know. What is this point? It is -0.4 plus j0. This is minus 0.8 plus J0. So now there are certain encirclements, but those encirclements are not on the critical point minus 1 plus 0 J. Therefore, we have n is equal to 0. P is already given as 0. Therefore, Z is equal to n plus P, that is equal to 0. That means when K equal to 1, system is absolutely stable as per the Nyquist stability criteria. Okay. It doesn't have any poles on right hand side. Okay. Yes. Then K equal to 2. Let us take. Say, for example, K is, yes, K is taking a value 2. That's where the problem is set. So K is equal to 2 means what will happen? Yes, that's why this characteristic equation is important. So it is K into G of S. 1 plus K into G of S is equal to 0. So this is the term we are looking for. What is going to happen means, so when K increases, the modulus of the K into G of J omega is also going to increase. So when K doubles, entire gain is going to double. Okay, that means remember that we are going to have K into G of J omega, angle also we are going to have. Okay, but it is K is not going to contribute any angle. So the phase angle of your Nyquist plot will remain same, but only the magnitude is getting altered when K increases. When K is 2, all the important points mentioned will get doubled. Okay, so that means this point is going to become minus 1.6 plus J0. And this point is going to become minus 0.8 plus J0. Then where is your critical point? The critical point is going to fall within this clockwise encirclement. This is minus 0.8, this is minus 1.6 somewhere. Anyway, it is getting encircled. So minus 1 plus J0. Yes, now you can see how many encirclement. This is number 1 and this is number 2. So the point, critical point minus 1 plus 0 J is encircled twice in clockwise direction. That's why I already said n is positive for clockwise rotation. Okay, clockwise rotation of this encirclement. So therefore, what is Z? Z is equal to n plus P, and P already known as 0. So is n is equal to, very simple problem. Nothing there once you know the basics of Nyquist stability criteria. Okay, so it is going to be 2 plus 0. So then Z is equal to simply 2. That means what? The given system is absolutely unstable. Why it is unstable? Because it has 2 roots. That means 2 closed loop poles on right hand side. Problem is not talking about the stability, simply how many closed loop poles on right hand side. So the answer is, probably he asked it as an integer. Okay, that's how I remember. So the answer should be fed as 2. 2 is the perfect answer. That's a very interesting problem. Okay, after a few years, okay, there is a problem based on Nyquist stability, I guess. So we'll update you with one more problem soon. Thanks for watching. Do subscribe our channel.